Okay, so to start off this Unit 2, we're going to start looking at fractions. So to deal with fractions, we talked a little bit on our first day about the two parts of a fraction. That top number, our numerator, is a count. It tells us how many. So this is telling us we have 3 of something, just like having 3 inches or 3 pounds or 3 cows. What is it we have 3 of? Well, we have 3/4. So the first thing we need to do is we need to define what a fourth is. And the simplest way to do that is to go back to the old elementary school drawing. Pretend that looks like a circle. Have a pie or a pizza or whatever. And fourths means it's cut into 4 equal pieces. Pretend those are equal as well. There's a reason why I'm a math teacher, not an art teacher. I can live with that. So there's 2 ways to look at it. You can either look at it as every whole object is split into 4 equal pieces, or it takes 4 of these pieces to make one whole object. And of course, we have 3 of those. So that's what we have right now. As we mentioned back on the first day, we go to add 2 fractions or subtract. We have to have the same name. So one of the first skills we need for working with fractions is being able to rename them. Probably the simplest way to rename them from this illustration is just to do this. Cut them into equal pieces. So we're going to cut each slice into 3 equal pieces. Once again, pretend they're equal. So now, how many slices, how many pieces does it take to make a whole thing? 12. We had 4, we cut each of them into 3, so 4 times 3 is 12. How many slices do we have? 9. We had 3, we cut each into 3, so 3 times 3 is 9. Do we have any more or less than we did before? No. No, we have the exact same amount. 9/12 is the exact same value as 3/4. We've just made it look different. And the reason we were able to do that is because of this right here. We multiplied by 3 over 3. And according to what we just said about fractions, the 3 on bottom says it takes 3 pieces to make a whole object. And we have 3 pieces. In other words, we have 1. We multiplied by 1. And anytime we multiply by 1, what does it do to the value? Nothing, right? It keeps it the same. This is what we call a unity fraction. You don't need to memorize this term, but it's something we're going to use a lot throughout math. When we get into measurement, unity fraction is how we convert measurements. It'll change its appearance, but it won't change its value. So here we just randomly chose 3 to be the number we multiplied by. Most of the time, we'll have a specific number we need to get to, a specific denominator. Let's, for example, say we have 2/5, and we need to change it to a denominator of 30. Well, we have to figure out what do we multiply 5 by to get 30. Perfect, 6. So what do we have to do to the 2? Multiply it by 6. So 2 times 6 is 12. Or we might have 1/3, and we need to change it to 15ths. Perfect. We had to multiply the 3 by 5 to get 15. So yes, 1 times 5 is 5. So here, 12 thirtieths and 2/5 have exactly the same value. 5/15 and 1/3 have exactly the same value. Sometimes we need to go the other way. If we want to reverse this process, we would just divide by 5 on both top and bottom to get back to 1 over 3. And we've already shown that those are equivalent. So here, we multiplied by 5, so we knew to divide by 5. The trick is, when we see a fraction that we want to reduce like that, figuring out what it is we can divide both of them by. For example, 48 over 60. Now, this is one of the reasons why we did the divisibility rules and stuff last class, was so we know how to tell what we can divide by. Now, a lot of us have been told that you have to divide by the largest number, the greatest common factor, we called it. It's not so. All you need is any number that can divide both of those evenly. What's any number that will divide those two? They're both even, so we can divide by 2. Now, some of you might be looking at it saying there's bigger numbers, but we found the 2, divide by it. 48 divided by 2 is 24. 60 divided by 2 is 30. And once we've divided by something, we've made them smaller, to me at least, it's a lot easier to see what else they can divide by. What else can they be divided by? What's that? 2 again. They're still both even. So 12 over 15, and still 3. So we get 4. 12 divided by 3 is 4. 15 divided by 3 is 5. So we get 4/5. Had you seen it right away, both of those could have been divided by 12. 48 divided by 12 is 4. 60 divided by 12 is 5. But again, you can see we got there just the same by taking any number we divided by, as long as it divides both of them. So if we have something like 33/55, both of those can be divided by 11. Perfect. I purposely threw one in there that your divisibility rules don't really work for. 33 divided by 11 is 3. 55 divided by 11 is 5. Or how about 8/32? Okay, if you see it, both of them can be divided by 8. Again, if you divided by 2, you would have got down to 4/16 and so on. That's 1/4. Okay, well, let's look at what happens when we run into something like this. 44 over 7. So the 7 is saying it takes 7 pieces to make a whole object. And we have 44 of them, which means we have enough to make not only one whole object, but several. How do we figure out how many whole objects we can get?
7 divided by 44.
Other way around. 44 divided by 7. There you go. If you punch that in your calculator, it's going to give you something like 6.285711429 approximately. What's that tell you?
You have 6 whole ones and whatever left over.
Okay, it goes in there 6 times. We have 6 whole objects with some pieces left over, but we don't know how many pieces. 2, perfect. Yeah, 6 times 7 is 42. There's 2 left. What we're basically doing here is a division and a remainder. 44 divided by 7. 7 goes into 44 6 times. 6 times 7 is 42. There's 2 left over, so 6 and 2 sevens. Make sense?
Did you really just guess right there?
This?
Yeah.
I knew that was right. I didn't guess. I've told you guys before, math is about patterns. The calculations are about patterns. Once you start to see the patterns, the calculations are very simple. I could go probably another 15 or 20 digits on that if I wanted to. Like I said, patterns.
Yeah, but I knew
So let's look at 23 over 5. We split that up. What's it going to become? 4 and 3/5. Good. Anybody have any questions where that 4 and 3/5 is coming from? 5 goes into 23 4 times with 3 left over. This is what we call an improper fraction. Improper is kind of implying there's something wrong with it, and there isn't. It's just fine. We just don't like having the numerator bigger than the denominator. This is what we call a mixed number. It's a mixed number because it mixes fractions and whole numbers together. Now, like I said, improper over here does not mean there's anything wrong. We just don't prefer it in that form. But there are times where we're going to need it as an improper fraction to work with it. So if we have something like 4 and 3/5, we want to turn it back into 23/5, the first thing we have to do is split this 4 whole objects into pieces. How many pieces do each of them have? 5. The denominator tells us that. So 4 times 5 is 20. So we get 20 pieces out of that, and we have to add it back to the 3 we had. 23/5. Back to where we started. Yeah. Whole number times the denominator tells you how many pieces are in the whole number, and then add it to the numerator that was already there. So if we have 7 and 2/3, it's going to be 7 times 3 is 21, plus 2 is 23/3. The denominator will never change unless we rename it. But going from a whole number or mixed number to improper or back again, it will never change. So how about 3 and 1/4? How many fourths? Perfect. 3 times 4 is 12 plus 1 is 13 fourths. So we can rename our fractions. We can move it from improper to mixed or back again. So now let's look at doing some operations with them. We talked about 1/3 plus 2/5. Those cannot be added or subtracted right now because they have different names. Now I'm going to set them up vertically just because that's how I'm used to adding. If you're used to adding horizontally, that's fine with me. But the first thing we need to do is we need to figure out what name we're going to change those to so that they are the same. Now some of you can probably look at it and just say what? 15. Good. There are a couple of ways you can go about finding that common denominator of 15. One, just take the two denominators, multiply them together. 3 times 5 will be 15. In this case, that's the smallest common denominator. I mean, it will always be a common denominator, but sometimes there will be smaller ones you could use. You can still use it. It doesn't matter if you use the smallest one. It's just more work if you don't use the smallest one. If you use a larger one, it's a little bit more work. You got to reduce later. Then you got to work with bigger numbers. What's that? Could have done 30, 45, 60, but you're working with bigger numbers. So now we have 100 would actually not work. Would have been 90 or 105. So anyway, another way we could find it is we got a 3 and a 5. We just count up, do multiples of 3. So 3, 6, 9, 12, 15, 18, and so on. Multiples of 5, 5, 10, 15. There it is. So we know that we have a common denominator of 15. The other option is, remember last class before our test, when we did factoring, we talked about least common multiples, where you do the factors. You could do that if you wanted to. If we were doing more heavy algebra and algebraic fractions with variables in them, that would be the easiest way probably to find the least common denominator, least common multiple. So now we have to change the names. What do we multiply 3 by to turn it into 15? 5. So what do we have to do to the 1? Times 5. 1 times 5 is 5. What do we do to the 5 to turn it into a 15? Times 3. What do we do to the 2? Also times 3. Makes 6. Now we can add. Remember, when we add, once we have the same name, we combine the counts and we keep the same name. So we're going to add 5 plus 6 is 11, and we just keep the 15th. So we're not going to spend any more time just adding simple fractions. We're going to jump up to mixed numbers. So something like 8 and 1/4 plus 5 and 1/6. To add these, I'm going to set them up vertically again. And we do still need a common denominator. 24. Actually, there's a smaller one. 12 will work. Now, a lot of books, when you do the common denominator, they don't rewrite the whole number. I always do that. I always bring the whole number over too, because sometimes I'll forget about it if I don't bring it with. But you don't have to if that's what you're used to. So what's going to go up here? 3. Good. How about down here? 2. So now we're going to add. Notice I put the fraction right at the end of the number, almost like it's the last digit of the number. And actually, that's what it is. The fraction is nothing more than the last digit of the number. Now that we have the same name there, we can add that last digit. We're going to start on the right and work our way back to the left, just like we do with any other number. 3 plus 2 is 5/12. 8 plus 5 is 13, so 3 carry the 1. There it is. Now you had said 24. What would have happened if we had used 24? Well, nothing really. This would have been 6 24ths and 4 24ths. We would have added 6 and 4 is 10 24ths. 8 and 5 is 13, but the 10 24ths can reduce to 12. We get the same way. We just have to take that extra step at the end of reducing. So it gets a little more complicated than that. If you haven't learned by now, I always make it worse. So let's take 8 and 7/8 plus 3 and 5/6. Still need your common denominator. What's it going to be? 24 will do it. What's going to go here? 21. Perfect. 8 times 3, so 7 times 3. What's going to go here? 20. 6 times 4, so 5 times 4. Now we're going to add 21 24ths plus 20 24ths is 41 24ths. We look at that, yes, it is an improper fraction. We can split that up. How many times can we take 24 out of 41? Once. What's left over? 17. 41 minus 24 is 17. So now, just like we did with our whole numbers, we're going to keep part of it and carry part of it. The part we're going to keep is our fraction. And we're going to carry the whole number, the 1. 1 and 8 makes 9, plus 3 is 12. So 12 and 17 24ths. I don't know why I just put 7 there. 12 and 17 24ths. Not a lot. I'm sensing a lack of faith there. So, I need a common denominator here. What's it going to be? 20. Good. What's going to go up here? 15. What's going to go up here? 8, right? So now we go ahead and add. 15 plus 8 is 3 20ths. So that's 1 and 3 20ths. So I will keep the fraction, the 3 20ths, carry the 1. Now we're still just working like whole numbers. 1 and 8 is 9, plus 7 is 16, so 6 carry the 1. 1 and 3 is 4, plus 9 is 13, so 3 carry the 1. 2 is 3 and 4. Not so bad? For subtraction, we're not going to mess around with simple fractions. We'll start right out with mixed numbers. So something like 8 and 4/5 minus 2 and 2/3. Common denominator will be 15. What's going to go up here? 12. There we go. 5 times 3, so 4 times 3. What's going to go here? That one will be 10. 3 times 5, so 2 times 5. Now we are subtracting, so it's 12 15ths minus 10 15ths. 12 minus 10 is 2. Keep the same name, just like addition. 8 minus 2 is 6. And of course, it gets worse. Yeah, words you never want to say in math. Yes, that ain't so bad. Common denominator. 24 would work, but we could also use 12. What's going to go up here? 3. Good. How about down here? 10. Now we go to subtract. 3 12ths minus 10 12ths. What do you run into? Can't do it, right? So we got to borrow from the 9. That's an 8. But I can't just put a 1 in front of the 3. What I borrowed was one whole object. How many pieces are in it? 12. My denominator tells me how many pieces are in it. So I have to add the 12 to it. Add my denominator to it. You got it. 3 plus 12 is 15 12s. And now I subtract. 15 minus 10 is 5 12s. 8 minus 3 is 5. Let's try another one of those. Let's do 341 and 1/3 minus 179 and, what do I put in here? 5/8. What's my common denominator? 24. This one will be 8, right? 3 times 8, so 1 times 8. What's this one going to be? 15. So, once again, 8 minus 15 can't be done. We borrow from the 1. It's now a 0. What do we have to do here? Add 24. Add the denominator. So it's 32 24s. You are correct. And now we subtract. 32 minus 15 is 17 24s. 0 minus 9, well, we got to borrow. This will be a 3 and a 10. 10 minus 9 is 1. 3 minus 7, we got to borrow again. This will be a 2 and a 13. 13 minus 7 is 6. 2 minus 1 is 1. What do you think? Still better than sharp stick in the eye? Okay. Multiplication. 3/4 times 2/5. When we multiply, do we need the same name? No. When we multiply, we also combine the counts, but then we also combine the names. So for fractions, that means multiply straight across. 3 times 2 is 6. Also combining the names then, 4 times 5 is 20. Now you look at that, you realize we can divide both of those by 2. It sucks when you get stuck in addition mode, doesn't it? Don't feel bad. A little ham by this time of the day, my little hamster's off the wheel half the time too. So we look at it. Some of you might be asking, why don't we cross cancel before we multiply? Or cross multiply, it's called in some books. Some of you might now be wondering, well, what's cross canceling? Well, we're going to multiply the 3 times 2. So it's going to be 3 times 2 on top and the 4 times 5 on bottom. If we look at that, we see that both the 4 and the 2 can be divided by 2. So we could actually divide that out before we multiply. 2 divided by 2 is 1. 4 divided by 2 is 2. Now when we multiply, 3 times 1 is 3. 2 times 5 is 10. So we've reduced before we multiplied. In a problem like this, it really doesn't, it makes no difference. It's about the same amount of work either way. But we can run into a problem like this, 24 25ths times 35 36. Now I could just multiply that straight across and get, what's 24 times 35 is 840. 25 times 36 is 900. Then I can reduce that. How many of you can look at that and see it's divisible by 60 for both of them? Sure. But it's easier if I look at this and say, hey, 25 and 35 can both be divided by what? 5. 35 divided by 5 is 7. 25 divided by 5? 5. 24 and 36 can both be divided by 6, somebody said. 24 divided by 6 is 4. 36 divided by 6? 6. I can still divide them by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. You could have divided by 12 if you saw it right away, but just like reducing a fraction, you can just keep dividing. You don't have to find the biggest one right away. So now 2 times 7 is 14. 5 times 3 is 15. 14 15ths. This would reduce that, by the way. Once again, we're not going to spend any more time with simple fractions. We're going to jump up to mixed numbers. We're going to do something like, oh, I don't know, 7 and 2/5 times 4 and 1/3. Multiplying mixed numbers is actually a pretty difficult process. In fact, if we went over here to the university and found 10 math majors, I'd actually be surprised if even one of them could show you the proper way to multiply mixed numbers. So how do we do it? There you go. We cheat. We're going to turn them to improper fractions. So this, now remember, the denominator doesn't change. So it's still going to be fifths and thirds. What's going to be here? 37. Good. 7 times 5 is 35. Plus 2 is 37. What's going to go here? 13. 4 times 3 is 12. Plus 1 is 13. Now we could cross cancel here if anything did, because it's still just multiplying. But there's nothing here that cross cancels. 37 times 13 is 481, yes. 5 times 3 is 15. So now we're going to do reducing that. 41 divided by 15. 15 does not go into 4, so that's a blank. 15 goes into 48 3 times. So 3 times 15 is 45. We subtract to get 3. Bring down the 1. 15 goes into 31 twice. 2 times 15 is 30 with 1 left over. So 32 and 1/15. In this part here, all you're doing is you're dividing how many times is 15 going to 41. Just doing the whole long division. Otherwise, you just do 481 divided by 15, you'll get 32. And then 32 times 15 is 480, so you can see there's 1 left over. Anybody want to see how you do this with the mixed numbers just for fun? Why not? Okay, good. There's a sadist in every crowd. So just like when we do something like 27 times 43, just like you have to do the 3 times the 7, but you also have to do 3 times 2. Same thing applies here. We have to do our 1/3 times 2/5. 1 times 2 is 2. 3 times 5 is 15. But we also have to do 1/3 times 7. How do I multiply a fraction times a whole number? You put the 7 over 1 to make it a fraction. So 1 times 7 is 7. 3 times 1 is 3. That is 2 and 1/3. Now I move over to the 4. The 4 has to multiply the 2/5. So I do the same thing. I'll make that 4 over 1 times 2 over 5. 4 times 2 is 8. 1 times 5 is 5. So that is 1 3/5. And then 4 times 7 is 28. Well, now we have to combine all that. Common denominator looks like it would be 15. So this will stay 2/15. 3 times 5, so 1 times 5 is 5/15. 5 times 3, so 3 times 3 is 9/15. 2 and 5 is 6. What did I do wrong there? What's that?
Yeah, I think that one is 2 and 5 is 7.
That's 2 and 1/3. What's this one? 8/5. That's 1 3/5.
Shouldn't that be 3/15, not 5/15?
Here? No, that's right. That's 5/15.
You added wrong.
I added wrong. That's why. Okay. 2 and 5 is 7, not 6. Plus 9 is 16/15, which is 1 and 1/15. So I keep my 1/15, carry my 1. 1 and 2 is 3, plus 1 is 4, plus 8 is 12. So 2 carry the 1. And plus 2 is 3. I get the same answer. It takes a lot longer, a lot more space, a lot more fractions, a lot more chances to screw up. I'm probably sticking with the improper fractions. I just wanted to show you it's possible. I'll never make you do that, by the way. Just so you know. What's that? Yeah. So let's do it back with improper fractions. Talk me through what to do here. Four times 5 is 20. So 22/5 times 3 times 3 is 9 plus 1 is 10/3. Now before we multiply, what should I do here? I can reduce the 5 and 10. Both divide by 5 to give me 1 and 2. So 22 times 2 is 44. 1 times 3 is 3. And we're going to go ahead and divide that out. Some of you might know that 3 goes into 44 14 times. 3 goes into 44, or 3 goes into 4 once. With 1 left over, bring down the 14. It goes in there 4 times. That'd be 12 with 2 left over. So 14 and 2/3. Any questions? Okay.
Well, you did it on the calculator and it came out in decimal, so you got 14 and 20.
Well, I'll look at the calculators in just a second. Division. We said that division follows the same rules as multiplication. Division is just multiplication done in reverse. So when we multiplied straight across. When we divide, can I divide straight across my fractions? If I do 12 divided by 14, I get 3. 25 divided by 5 is 5. Is that the right answer? Sure is. Does that work every time? Sure does. Why don't we do it? Well, because we run into things like this. There we go. 3/4 divided by 2/3, it doesn't divide out evenly. 3 divided by 2 is 1.5. 4 divided by 3 is 1.33333. So that one doesn't work out so nicely. How have we been taught to do this? The first fraction doesn't change. The second one, do we do what? We flip it. Reciprocal, right? Is the big word. And then we multiply. Some of you were taught something called the crisscross or zigzag method, where we do this. That's just a shortcut for doing the multiplying by the reciprocal. I don't like that because it makes a lot of mistakes. But if that's the way you're taught, go ahead and do it. So we take the reciprocal of this second number. The reciprocal means you just flip it over, exchange the numerator and denominator. So 2/3 becomes 3/2. And then we multiply. So 3 times 3 is 9. 4 times 2 is 8. 9/8 or 1 1/8. Believe it or not, that process of multiplying by... Did you have a question? I heard somebody say something. Okay. That process of multiplying by the reciprocal comes from this process I just showed you up here of dividing straight across. So you're probably wondering, they don't look like it. Well, once upon a time, the way this division was done, before they started doing that multiplying by the reciprocal, we would look at this fraction that we're dividing by. It's reduced as far as it can go. So now we're going to multiply the numerator times the denominator. 2 times 3 is what? 6. So now we're going to use that 6 to rename our fraction, 3/4. So we're going to multiply by 6 on top and bottom. 3 times 6 is 18. 4 times 6 is 24. Now remember, 18/24 and 3/4 are the same value. We just made it look different. And now we're going to divide that by the 2/3. So now if we divide straight across, 18 divided by 2 is 9. 24 divided by 3 is 8. 9/8 or 1/8. Just what we got before. Well, how on earth did we get from this to multiplying by a reciprocal? It's not as different as you would think. At some point, someone looked at this and said this is 3/4 times 6/6, then divided by the 2/3. And what they realized is if we stretch our order of operations a little bit, if we divide this part first, we have 3/4 times whatever that result is. 6 divided by 2 is 3. 6 divided by 3 is 2. What we get here is always just this fraction flipped over. So rather than going through this whole process, they defined this to be called a reciprocal, and they said, hey, when we divide, we're just going to multiply by the reciprocal.
To get that number that goes first, you would just flip both, or just times the...
Yep, numerator times denominator, you get this, yeah. And that's why, because of that, when you divide by it, that's why it just ends up flipping over and giving a reciprocal. Now, we're not going to do it that. We're just going to take the reciprocal and multiply because that's how we've been taught. But it's nice to know where it comes from. There's actually a deeper process there. Okay, so let's jump up to some mixed numbers. Let's do 5 1/4 divided by 2 and, oh, what do I do here? 2 and, remember one of those days where the hamster just won't get on the wheel? It's one of those days. 2 and 1/6. We'll see what happens to that. So anyway, it makes sense if we're going to turn this into multiplication, that we'll handle it the same way we did for multiplication. We're going to turn it into improper fractions. What's going to go here? 21, right? 5 times 4 is 20 plus 1 is 21. What'll go here? 13. Is this multiplication now? No, it's still division. Can we cross cancel? No, because we can only cross cancel in multiplication, not multiplication yet. Now the first number never changes. When we subtract or divide, it's always the second number that changes, right? So it's going to be times, what's going to go here? 6 over 13. We flip it over, take its reciprocal. Now we can cross cancel. We have 6 and 4 both divisible by 2, giving us 3 and 2. 21 times 3 is 63. 2 times 13 is 26. 26 goes into 63 twice, with 11 left over. What do you think? Good stuff? Let's do one more. Let's do 8 and 2/3 divided by let's see, what is that going to be? What is this? You guys tell me what to do. 26 over 3, good. 13 over 5, still divided, right? Perfect. The 26 over 3 doesn't change, but this does become 5 over 13. And then I can reduce 26 and 13, right? 2 and 1. Okay, and then 2 times 5 is 10. 2 times 1 is 3. Goes into 3 times with 1 left over. 3 and 1/3. Not so bad? How many of you have a fraction calculator? Okay. Those of you who don't, I actually had just discovered, a student brought me this. It's an app you can download on your smartphone. I have not downloaded it myself, but I looked at it on his. It's called Calctastic. It's a scientific calculator with fractions. You found one of the fractions?
Yeah, Mathway.
What is it called?
Mathway.
Math?
Yep.
Way?
Yep.
All one word?
Yep.
Okay. That has the fractions on it too? Well, I'll check that one out sometime.
You try it. You're going to come back tomorrow and be like,
Is there a way to do fraction with this?
Not, actually the Casio does do fractions. You got an ABC.
Yeah.
So I'll
How
show
would
you.
you punish
I'll
something
do it
like
when I'll
that?
show everybody else. I'll show you yours.
Okay.
That's the same as everyone else's.
Okay.
Okay, so most of you, if you have a fraction calculator, have a key that looks like this, ABC. That is the key to entering fractions. Some of you, if you might have like a Smart View or a math type calculator, it might be UND or something like that. So anyway, to enter a fraction in that calculator, say you want to do 3 and 1/5. You would type 3, press that key, 1, press that key again, and 5. Hit equals, it should display it as 3 and 1/5. May not look perfect, but you can tell what it meant, what it means. So try to enter this. Try to enter 21/35. So 21 ABC 35, and what does it display? 3/5. So it automatically reduces them for you. What's that? Okay. If you have something different, we'll look at it for you in a little bit. Try to do this. Try to enter 28 over 6. 28 ABC 6. 4 and 2/3. So not only does it change it to a mixed number, but it also reduces the fraction again. So now then you can do that to do any of these calculations. If we go back up to this one we just did here, 8 and 2/3 divided by 2 and 3/5. Try to enter that in your calculator and see if you can get it to come up to 3 and 1/3. You're just still downloading?
you got to figure out how to get 3 and 1/3.
Does come to 3 and 1/3. Perfect.
It takes mastery to do it.
I want to try something.
I've seen a couple out there that have fractions on them, but they don't work correctly. What's this problem here? It works just the same, right? So homework for next Tuesday, page 32 to 33, 1 through 49, the odds. That's just on renaming fractions. Page 41 to 45, 1 through 89, the odds. That's going to be on adding and subtraction. And page 49 through 52, 1 through 87, the odds. Multiplying and dividing. Now, as always, if you do one or two of the first ones and they're easy, jump ahead. You don't. I'm not sending you home with 107 homework problems here. If you're not very good at it, well, you might need to practice. Like I said before, if I asked people at the beginning of class what was the topic they struggled with most in math, generally 4 out of 5 or so would say fractions. So if you're struggling with them, be patient. I don't, after we do these for a couple days, I don't mind if you just switch over to the calculator and start doing that. So I'll have you take your last 15 minutes here to get started on your homework. You might be able to finish.